Welcome to the deep dive. We've got something really interesting lined up today. We're digging into some source material a listener sent over.
Yeah. What's it about?
It's all about a test you might have heard of, especially if you're into high-intensity training or sports performance. The Wingate Anaerobic Test.
The WAT. Right. The classic, 30-second all-out cycling blast. Developed back in the 70s, I think. It's designed to really push your anaerobic performance, measuring how well those immediate energy systems hold up. The ATP PCR for that initial burst, and then the glycolytic system that follows. Maximum demand stuff.
And this listener, they shared a really detailed review paper. It's like a deep dive within our deep dive, you could say. And it focuses specifically on all the different things, the variables that can actually influence the results you get from the Wingate.
Ah, okay. Because, on the surface it sounds simple, right? Just pedal super hard for 30 seconds.
Right. But this source, it really unpacks how much is going on behind the scenes. So many little factors can change the numbers.
Gotcha. So our mission today is basically to walk you, the listener, through this source material, highlight the key details.
Yeah, so you can understand not just what the test involves, but why certain things matter so much, whether you're, taking the test, administering it, or just looking at the data afterwards.
Makes sense. Getting beyond the basics.
Okay, so let's unpack it. The core idea, like we said, pedal maximally, as hard and fast as you possibly can.
Against a set resistance.
For 30 seconds.
Yeah.
What are the main things we actually learn from that effort? What data comes out?
Well, you get three main metrics usually. First up is peak power, PP.
Peak power. So that's the absolute highest power you hit.
Exactly. Usually happens pretty early on, like in the first few seconds. And what peak power tells us, well, what do you think it reflects most?
That sounds like the initial explosive punch, right?
Yeah.
Heavily reliant on that ATP PCR system. Pure power, how fast you can, recruit everything.
You got it. It's that immediate power capacity. The source is pretty clear that peak power is generally a very reliable metric.
Reliable meaning? Meaning,
if you test yourself under the same conditions, you're likely to get very similar peak power numbers each time. The consistency is good, often above, R0.90 in the studies mentioned.
Okay, that's solid. What's next after peak power?
Then you have mean power, or MP.
Mean power. So the average over the whole 30 seconds.
Yep. The average power output across the entire test. This gives you maybe a broader picture. It represents more of your total anaerobic capacity.
So it includes both the initial burst and how well you sustain it using that glycolytic system.
Precisely. The contribution of both energy systems over the full duration.
And is mean power reliable too?
Also quite good, yeah. The source cites reliability coefficients that are typically between 0.91 and 0.93. So like peak power, mean power is generally seen as one of the more robust, trustworthy outputs from the Wingate.
Okay, PP and MP are pretty solid. What's a third metric?
That would be the fatigue index, or FI.
Fatigue index. Sounds like it measures how tired you get.
Sort of, yeah. It tries to quantify how much your power drops off. From that peak you hit early on down to where you finish at the end of the 30 seconds. It's often shown as a percentage drop.
And what's that supposed to tell us?
Well, the idea is it reflects your rate of fatigue during that intense anaerobic work. Maybe relates back to your overall anaerobic capacity, how quickly you burn through everything.
Okay.
But, and this is a really key point the source highlights, the fatigue index is significantly less reliable than peak power or mean power.
Less reliable. How much less?
The source mentions reliability coefficients for FI ranging pretty widely, sometimes as low as 0.43, maybe up to 0.73. That's a much bigger spread.
So if you took the test multiple times, that fatigue index number could jump around a lot more, even if your PP and MP were fairly stable.
Exactly. It's just not as consistent day to day. So as a standalone measure of capacity, it's maybe a bit shaky.
But I think the source mentioned it can still be sensitive to training. It might show changes over time.
That's right. Even if the number itself is less reliable session to session, if you're doing consistent training aimed at, say, improving fatigue resistance, you might see a trend in your fatigue index improving over weeks or months.
Okay.
Oh, and one other quick thing, the time it takes you to actually reach that peak power, that might also offer some clues. Maybe about muscle fiber types, or how quickly your nervous system can recruit motor units, how fast you can ramp up to max force.
Interesting. So peak power for the initial bang, mean power for the overall anaerobic effort, and fatigue index for the drop-off, though you need to take that one with a grain of salt.
Which pretty much sums it up.
So why is this whole idea of reliability so important for you, the listener, if you're using this test. Why does it matter if L of I is a bit flaky?
Well, that's really the crux of it, isn't it? If a test isn't reliable, you just can't trust the numbers day to day.
Yeah.
If you get wildly different scores each time, even under what seem like similar conditions, how do you know if your training is actually working? Or how can you compare your results to someone else's or even your own past results accurately?
Yeah, the noise obscures the signal.
Exactly. And the source even points out something interesting here, just doing one familiarization test before the real recorded test. That alone can improve the reliability of PP and MP.
Just getting used to it helps.
Seems so. Though, interestingly, it doesn't really fix the reliability issues with the fatigue index much. That seems inherently more variable.
So doing the test totally cold, first time ever, probably not going to give you your best or most representative numbers.
Likely not. Familiarity definitely matters.
Okay, that makes sense. So let's dive into the real meat of this review paper, all those variables that can affect the numbers. Where should we start?
Well, one of the first big ones the source tackles is test duration itself. The standard is that 30-second all-out sprint.
Which is notoriously brutal, right? That heavy glycolytic effort leads to serious acidosis. The burn is real.
Oh, absolutely. It's definitely not pleasant. And that discomfort, that metabolic stress, has led researchers to ask, is the full 30 seconds always necessary? Or even optimal?
Good question.
The source highlights findings that shorter durations, maybe like 20 seconds, can actually still give you pretty reliable data for predicting what your 30-second peak power and mean power would be.
Oh, interesting. So you could maybe get a good estimate without the full 30 seconds of agony.
Potentially. And even shorter tests, like really short 6 to 10 seconds, those might be enough if your only goal is to measure that initial peak power.
Just the explosive bit.
Right. A shorter test could give you valid peak power data, perhaps with less acidosis, less discomfort.
But what about the flip side? Does the source mention needing longer tests sometimes?
It does, yeah. Especially for highly trained athletes. Think elite cyclists or rowers, people with really well-developed anaerobic systems.
For them, 30 seconds might not be enough.
Exactly. For them, a 30-second test might actually be too short to fully challenge their total anaerobic capacity. The paper mentions that durations of maybe 45 to 60 seconds, or sometimes 40, 50 seconds, are occasionally suggested as being more appropriate for really taxing those elite systems.
Okay, so duration isn't fixed in stone. It really depends on who you're testing and what specific aspect of anaerobic performance you're trying to nail down.
Definitely. Flexibility based on the goal and the subject. That's a key takeaway.
Got it. What's another major variable the source points to?
Cycloergometer resistance. This is a huge one. The original Wingate protocol, way back when, specified using a resistance equal to 7.5% of the person's body mass. So 0.075 kilograms of resistance per kilogram of body weight.
Okay, 7.5% body weight. And the big finding here, based on this review?
That original resistance is often insufficient for most adults.
Insufficient, meaning too low.
Yeah, too low to actually elicit their true maximum anaerobic power, particularly peak power.
Wow, okay. So the standard might be holding people back.
According to this review paper, absolutely. It shows pretty consistently that to get someone's best possible numbers, especially that peak power spike, you often need a higher resistance than that original 7.5%.
And is there one new right resistance?
Not exactly. The optimal resistance isn't a single fixed number. It varies quite a bit based on factors like gender, training status, and especially body composition. Things like your lean muscle mass seem really important.
So just basing it on total body weight, like the original did, isn't really the best approach for everyone.
Probably not, according to this research. The paper points out that the ideal resistance to maximize peak power is typically higher than the ideal resistance to maximize mean power.
Oh, interesting. So the best resistance for the start isn't the best for the whole 30 seconds?
It seems that way. The source mentions various studies finding optimal resistances ranging higher, maybe 0.087 kilogrammes, 0.095, even up to 0.105 kilogram, or sometimes suggesting basing it on lean mass instead of total body weight.
That's quite a jump from 0.075.
It really is. And the source also notes that the type of start you use matters here too.
How so?
The original Wingate often used a jump start. You'd get the pedals spinning fast before the resistance was applied. Many modern tests use a stationary start, where the resistance is there from the first pedal stroke.
Right.
The paper suggests that with a stationary start, particularly on modern ergometers, that original 0.075 kilogate Kalongo might be okay for, say, recreational athletes. But for trained folks, or if you're really chasing that true peak power number, higher resistance is still generally recommended.
Okay, this is crucial. Why does getting this resistance exactly right matter so much for you, the person taking or analyzing the test?
Because if the resistance isn't optimal for you, you're simply not going to hit your maximum potential. It's that simple.
How come?
Well, if it's too low, you might not fully engage your strongest muscle fibers. You might just spin out too fast. If it's too high, it could bog you down, prevent you from reaching peak pedal speed and power. Either way, the power numbers you record won't reflect your true peak performance.
And they won't be comparable.
Exactly. You can't reliably compare your results to previous tests or to others if the resistance wasn't appropriate each time. It's fundamental to getting meaningful, usable data.
Okay, so duration and resistance are definitely huge factors needing careful consideration. What else did this review paper dig into?
Warm-up, another really critical one. The source talks about the original warm-up protocols and also newer recommendations, like those from the U.S. Olympic Committee. They often involve some sub-maximal cycling, plus maybe a few short, hard sprints.
Makes sense. You wouldn't want to go from 0 to an all-out sprint cold, right?
You wouldn't think so.
Yeah.
But the research here has some interesting twists.
Like what?
Well, for instance, one study found that in children, doing a warm-up improved their mean power, the average over 30 seconds, but didn't necessarily boost their peak power.
Okay.
But for trained athletes, the findings were almost counterintuitive. A traditional, longer warm-up, it could actually impair their peak power output.
Wait, the warm-up could make their initial burst worse?
The thinking is it might cause some fatigue before the main test even starts. You burn through some of that immediate energy reserve.
It is surprising.
It is. So for trained subjects, the source suggests maybe a shorter, lower intensity warm-up might be better for maximizing peak power. Or, alternatively, a warm-up that includes some specific high-intensity sprints after a submaximal phase could be effective.
So the warm-up itself needs careful design.
Absolutely. The key takeaway the source really hammers home is that the warm-up protocol needs to be standardized for whoever you're testing and probably tailored to their training level if you want consistent or reliable results.
And didn't you mention something about stretching earlier related to warm-ups?
Yes. The paper specifically mentions a study showing that doing static stretching, holding a stretch for 20-30 seconds before the Wingate significantly reduced power output.
Reduced it. Wow, so maybe dynamic movements are okay, but skip the long static holds right before the test.
That seems to be the implication from that study, yeah. Good practical tip.
Okay, so we've covered the test mechanics, duration, resistance, warm-up. What about external factors? Did the source look at things like supplements?
It did, yeah. Though this is a really complex area, the paper is careful to point out that the effects of supplements can vary a lot. It depends on the specific substance, the dose, how long you take it, and even just individual response, whether you personally are a responder to it or not.
Right. Supplements aren't magic bullets for everyone. What did they find for some common ones people might try?
Okay, so sodium bicarbonate, that's baking soda, basically used to buffer acidity. The results from single doses were kind of mixed in the studies reviewed, but one meta-analysis mentioned suggested that chronic intake, taking it regularly over time, might improve both peak and mean power.
Interesting. What about creatine? That's often linked with power.
Creatine showed more consistently positive effects in the review, particularly when used properly, meaning sufficient duration and dosage, like doing a loading phase first, seems to line up with its known role in the ATP-PCR system.
That makes sense. How about alanine? Another buffer?
Alanine, yeah. The results mentioned were more mixed, especially for tests under 60 seconds, like the standard Wingate. The thinking is it might be less effective for these super short, intense bursts compared to slightly longer, high-intensity efforts where buffering becomes even more critical.
Okay. And the classic pre-workout ingredient, caffeine.
Caffeine is an interesting one. Some individual studies didn't show a clear effect. However, the source does cite a meta-analysis that found a significant overall benefit for both peak power and mean power when using caffeine compared to a placebo.
So on average, it helps.
Seems so, according to that analysis. But again, the paper stresses individual differences. Some people respond well, others don't. And if you drink coffee every day, you might build up a tolerance, potentially reducing the performance boost on test day.
Right. Tolerance is key.
It does seem to offer potential benefits for both trained and untrained individuals, though, which is interesting.
Any others stand out?
Nitrate supplementation, like from beetroot juice. Some studies mentioned showed potential improvements, maybe in peak power or how quickly you reach it. Others were less clear-cut. Nicotine didn't seem to help in one study. There was mention of a specific gold root extract showing promise in one 15-second test study, and arginine didn't show significant benefits in the studies reviewed.
Okay, so it's definitely a variable landscape with supplements. Some like creatine, caffeine, maybe nitrate show more positive signals in this review, but it's very dependent on context and the individual.
That's a good summary, yeah. Always keeping that individual variability in mind. Now, here's a really fascinating variable the source touches on: genetic factors.
Whoa, genetics. Influencing a 30-second bike sprint. How?
It points to some intriguing, though still early, research linking specific variations in certain genes to anaerobic performance.
Like which genes?
Well, the ACTN3 gene, sometimes called the sprint gene, the results mentioned in the paper were actually contradictory across different studies, so that one's not clear-cut yet.
Okay.
But variations in other genes like AMPD1, PPRRA, MC21, and UCD2 showed potential positive associations with things like peak power or mean power in some studies reviewed.
So does that mean some part of your raw anaerobic potential might actually be influenced by your DNA code?
Potentially, yeah. It raises these fascinating questions about inherent predispositions for power versus endurance, for instance.
But it's early days.
Very much so. The source is really clear that this area needs a lot more research. We're nowhere near saying this gene equals this Wingate score, but it's a glimpse into the possible biological underpinnings of performance differences.
Really interesting area to watch. Okay, so we've hit duration, resistance, warm-up, supplements, even genetics. What other kinds of variables, maybe less obvious ones, did the source highlight as potentially messing with Wingate results?
Oh, there were quite a few. Some are things you might just encounter in daily life, stuff you wouldn't immediately think affects a max power test.
Like what? Give me some examples.
Okay, how about time of day when you actually do the test?
Did that make
Well, the results were a bit conflicting across studies, but some research mentioned found better performance, especially peak power, in the afternoon or evening compared to the morning.
Huh. So maybe don't schedule your Wingate test for 7 a.m. if you want your best possible score.
The research might suggest that, yeah, at least for some people, diurnal rhythms and all that, then there's bike setup that's huge.
Beyond resistance.
Yeah, just using proper cycling cleats versus flat pedals, that generally improves scores. Saddle height is also critical. The source suggests aiming for a knee angle somewhere between 25 and 35 degrees at the bottom of the pedal stroke for optimal power.
Makes sense.
Other things, like the specific saddle angle or using those oval-shaped chain rings, they seemed less impactful in the studies reviewed. But the type of ergometer, the bike itself, definitely matters.
Oh, so?
Different types, like the older mechanical friction-braked ones versus newer electronically braked ones, magnetic, can give different results, especially for mean power and those older mechanical bikes. Friction in the system can actually make them underestimate your true power output. Even the size of the chainring used can modify results.
So the actual equipment and how it's dialed in are definitely not minor details. You need consistency there, too.
Not at all. And even simpler things matter. We mentioned familiarity earlier. Just having done the test before improves your results compared to the very first time. Your body and mind just know what to expect, how to pace, how much it's going to hurt.
The learning effect.
Exactly. And remember the stretching point. Static stretching before the test seems to decrease performance. That came up again.
Right. Avoid those static holes. What about things like hydration or sleep?
Yeah, interestingly, the source mentioned studies where mild dehydration, like losing 2% to 5% of your body weight in fluid, surprisingly did not seem to decrease Wingate power output.
Really? That is surprising. I'd assume dehydration would hurt performance.
Me too. But that's what those specific studies found for this short maximal test. Maybe it's just too short for mild dehydration to have a major impact on the anaerobic systems. Sleep deprivation, though, did show an effect.
How much?
According to the study cited, going 24 hours without sleep didn't cause a decrease, but pushing it to 36 hours of sleep deprivation did cause a significant drop in performance.
Okay, so pulling one all-nighter might be okay, but definitely don't try for 2 before a Wingate test.
Probably very wise advice based on this research, yeah. What else? Compression garments. One study mentioned showed they improved mean power, but not peak power or fatigue index.
Interesting. Diet.
Diet showed mixed results. A short-term Mediterranean diet didn't seem to improve Wingate performance in one study. Intermittent fasting, however, decreased peak power in another study. Carb loading didn't really change power output itself, but it did affect total work done and some physiological markers.
So diet effects seem complex, too.
Very. And even just having someone yelling encouragement at you, verbal motivation, also mixed results. Some studies found it improved mean power, others didn't see a significant effect.
Huh. So, come on, push harder. Might or might not work.
Seems like it depends. And finally, environmental factors. Things like moderate altitude changes primarily affect aerobic performance, so less impact on the Wingate. Temperature and humidity within the ranges studied in the cited papers didn't show significant differences in peak power. Even how you breathe mouth versus nose didn't make a difference in one study.
Wow. Okay. That's a lot of factors. Time of day, sleep, maybe hydration, maybe not, what you ate recently, whether you stretched statically, the specific bike you use, how it was set up, if you'd done the test before, your genetics maybe, whether someone cheered you on. It feels like almost everything under the sun could potentially nudge the results of a 30-second sprint test one way or another.
It really highlights just how sensitive this type of maximal test is, doesn't it? And I think if we step back and look at the big picture, the sheer volume of these potential influences is really the key insight from this review paper.
Yeah.
The Wingate test itself, it's a powerful tool for assessing anaerobic performance, no doubt about that. But getting truly reliable, meaningful, and comparable results, that's clearly much more complex than just telling someone to hop on a bike and pedal as hard as they can for 30 seconds.
It requires real attention to detail.
Meticulous attention, yeah.
Yeah.
To controlling as many of these variables as humanly possible.
So let's bring it all together. What does this all boil down to for you, the listener? If you're thinking about taking a Wingate, or maybe you supervise testing, or you're just trying to make sense of some results you've seen.
I think the main message is that understanding these variables is absolutely critical. It's not enough just to do the 30-second effort. You have to consider the whole context.
Like asking the right questions.
Exactly. Was the test duration appropriate for the person and the specific goal? Were they just looking at peak power or overall capacity? Was the resistance really optimal, or was it just the old standard? Was it based on body weight or maybe lean mass? Was the warm-up consistent every time? Was it appropriate for the athlete's level?
And were other things accounted for?
Right. Were potential influences like caffeine intake, sleep levels the night before, or even static stretching controlled for, or at least noted? Especially if you're trying to compare results over time to track progress.
So standardization is key.
Standardization is absolutely paramount if you want accurate data, if you want to track progress meaningfully, or if you want to compare individuals or groups fairly. It means acknowledging all these variables we've talked about and probably adjusting protocols based on current research, like the strong suggestions in this paper to use higher individualized resistance levels for most adults.
Yeah, this deep dive into the source material really hammers home that the classic 30-second Wingate with that fixed 7.5% resistance. It's really just the starting point, the foundational concept. Applying it effectively, accurately, reliably today means really getting into the weeds. Adjusting duration, individualizing resistance, being precise about warm-ups, and just being super aware of all these other potential influences the paper laid out.
It's definitely a testament to the complexity of measuring human performance, even in something as seemingly simple as a 30-second burst. The test's value is really maximized when you approach it with this kind of informed control and understanding of the nuances.
It makes you think, doesn't it? Considering how many different factors can sway the outcome of just one super intense 30-second effort. What does that tell us about the challenges of measuring performance in longer, more complex sports, or even just understanding our own day-to-day physical capabilities?
That's a great point.
And how much might these same kinds of variables, things like sleep, maybe hydration, your warm-up or lack thereof, maybe even your stress levels or what you ate, how much might they be impacting your performance every day, even when you're nowhere near a lab or a formal test?
Yeah. Definitely something to ponder. How much untapped potential is there just by optimizing some of these basic factors?
Food for thought. Well, that brings us to the end of this deep dive. Thanks for joining us.
See you next time.